All right. So now, part two, we're going to do electron configurations for ions. So it says, you may recall that many elements will lose or gain electrons to obtain the same number of electrons as a noble gas. That is true. Noble gases are the most stable, so all the other elements are going to try to have the same configuration as a noble gas because it's the most stable, most favorable. We've talked about that. So if two atoms have the same number of electrons, they are said to be isoelectronic. In other words, they have the same electron configuration, same structure of their electrons. So we know that all of chemistry has to do with how the outer part of atoms interact with each other. So the electrons, how electrons interact between other elements and combine and make themselves more stable. So if you have an element that is isoelectronic to another element, it's not going to be perfectly the same, but they're going to have similar properties because they have the same type of outside configuration of electrons out on the outside of their shell. So they interact with other elements in a similar way. Makes sense? Okay. So for this one, it says, what is the electron configuration for the following ions? I'm gonna fill this out first. Why not? Okay. So, well, oxygen has 8, right? But this has O negative 2. So what that means is we have 2 extra electrons, all right? So why don't we just start from the top? So 1s, 1s2, because we fill that. So remember, if we have a negative 2, we have 2 extra. That means we have 10, all right? 2s2, and then 2p6 gets us to 10. So what other element has 10 electrons? It's going to be neon. So it is isoelectronic with neon. I'm just going to do any. All right. So it says, although O negative 2 and Ne have the same electron configuration, they are not identical. And yet, they're not perfectly, they're not like oxygen negative 2 is not now a noble gas. They are not identical. They will share some properties when that happens. In terms of bonding to each other. I know noble gases usually don't. They actually do. It was kind of not the best example for that. But, yeah, properties do change when you have an ion. Okay? So properties of elements do change. Okay, we have, what is this? Rubidium? Yeah, rubidium. So +1. So if we have +1, that means you go back down. You lose an electron, right? So for this one, rubidium, instead of going to 37, we're going to go to 36. We could, might as well just do this. We'll fill it in. All right. So we have 1s2, 2s2, just going through, 2p6, it's also just written there, 3s2, 3p6, 3d10, and then 4p6. So Rb plus 1 is isoelectronic with krypton, Kr. All right. With these, pretty easy to, again, for these we just count our number of electrons, If this has a +2 charge, which means it's 2 less than it normally has. So just imagine if we had another 2 right here, this would be down to 3s, so that would be 2, 4, 12, which would be magnesium. So Mg +2, and that's going to have the same configuration as neon right there. This one, 2, 2, 6, 10, 2, 18. -3 charge means it has 3 more electrons than it normally has. So phosphorus, that is going to be P -3. That's going to be equal to argon, Ar. All right. We'll do the next one soon.